In our previous video of fluid mechanics, I mentioned that we are going to solve past questions on the different conservation laws under fluid dynamics. Now this is under conservation of mass. Now this is past questions 2024/2025 past questions. Now the question goes like this: a tempered pipe flowing with water has velocity of 2 meter per second at section 1.1 if the dimension of the pipe are 200 millimeter and 350 millimeter at section 1.1 and 2.2 respectively. Find the velocity of flow at section 2.2 and the discharge through the pipe. Now first of all, solution. Now let's list out our parameters. You can say given that our velocity, which is our first velocity v1, the velocity of 2 meter per second was given. If the dimension of the pipe, these are the two diameters or dimension of the pipe, d1 and d2. You say we should find the velocity, which is the second velocity, is unknown, and the discharge also, q, is unknown. Now first of all, note in fluid mechanics we don't leave our diameters in millimeter. You have to convert it to meters. Now converting 200 millimeter to meters, we divide 200 by what? 1000. Now when you divide 200 by 1000, you get 0.2 meter. Now also for the second diameter, 350 divided by 1000, you get what? 0.35 meters. That will be our second diameter. Now after doing this, you can see applying the formula of discharge, which is q is equal to what? A1 v1 is equal to what? A2 v2. Right now, we looking at this formula, we have gotten v1, which is what? 2 meter per second. We don't know a1, we don't know a2, and we don't know v2. Now we know that area itself is equal to pi d square over 4. So for a1 will be equal to what? Pi d1 square over 4, right? Which is what? 3.14, because our pi here is 3.14 times the first diameter here, which is 0.2 meters, 0.2 meter square over 4, right? Now the whole of this is going to give us, the whole of that is going to give us 0.031. If you do it, you square this, you get your answer, times it with this, now divided by 4, you get this for a1. Now we have gotten a1, we have gotten v1, it's remaining a2 and v2. Now for us to get a2, consider a2 will be equal to what? Pi d2 square over 4, right? Which is equal to what? 3.14 times our d2 here is what? 0.35 all squared over 4. The whole of this is going to give us, the whole of that is going to give us 0.096. Now from here, now we can impute or substitute this value of a1, a2 and v1 into the equation for us to get v2. So now we can see that a1 v1 is equal to a2 v2. Our a1 here is what? 0.031 times our v1, which is 2, is equal to what? a2, which is 0.096 times our v2. Now for us to make v2 subject of the formula, we divide both sides by what? 0.096. Divide here also by 0.096, so that our v2 will be equal to what? 0.031 times 2 over 0.096. Now this as a whole is going to give us what 0.65 meter per second. Now if you want to look at this very well, you can see that the difference between the first velocity here and the second velocity here, there's a big difference, because now the v1 is representing what, the diameter of the first pipe, which is 200 millimeter, and this also v2 is representing the velocity of the diameter of the diameter of the other pipe. So if this, the v1 is larger than the v2, that means when the diameter was 200 millimeter or 0.2 meter, the speed was higher. So if, for example, let me illustrate it like this. If this is the pipe here, and this is what, this is our section 11, which is what, our 200 millimeter, right? And this is our section 22, which is our 350 millimeter. The speed here was what, 2 meter per second, and the speed here was what, 0.65. So the smaller the pipe, the faster the speed of the water. So if the speed of the water was rushing here at 2 meter per second, when it gets to here, it reduces to what, 0.65 meter per second. So we can assure ourselves that we are correct, since this is lesser than this. So we can go further to calculate our discharge. Now discharge is equals to what, A1V1 is equals to what, A2V2. Either you use this or you use this to get discharge, or will still give you the same answer. So let's take this. Discharge is equals to A1V1, and our A1 is given to be 0.031. So 0.031 times our v1. Our v1 is given to be 2 meter per second, so times 2. So this is going to give me, should probably give me 0.062 to be my discharge.